Hello my dear students, let's have a look at the diagram below shows two histograms of mathematics test marks obtained by two groups, Arif and Bestari. Let's have a look at mathematics test marks of Arif groups. The marks looks almost uniform because you see the lower mark, the frequency is almost 2 4 3 2 4 something like that. Is almost uniform. Number of students who's having low marks and high marks are almost not far, the difference, isn't it? So when you see the test mark for Vestari group, those students who score very high marks, the quantity are many, right? We have more students. Example 60 to 70, between that interval, we have 8 students. So those students who score high marks are quite many. And we have one special case whereby 2 students score very low marks. That's called extreme values. Okay, so it's overall it looks like a bell shape, but we can see there is extreme value. So we will say this is a bell shape with extreme values. All right, so you must know how to do comparison between the distribution of the marks. Okay, now let's see this one. This one is actually looks like a bell shape. Bell shape means the number of students who score low and the high are less, and majority of them are actually between mean mark, so you can see that that is the one that I circle in red color is so-called extreme values, because that marks is actually too far from the majority of the students mark, you see. So we call extreme values. Okay, so this is a bell shape with extreme values. Remember that? Now I'm going to discuss what it means by dispersion. Okay, dispersion. Now let's see. You can see that Arif group's marks are almost uniform. And then we can also say that we want to do the comparison now between these two groups of marks, between the dispersion between the Arif group and the Bestari group. What it means by dispersion, basically dispersion is actually how the data or how the marks change from lower to higher marks. So normally we will focus to the range of the marks, you see. So we can observe that from 10.5 to 90.5 is quite, the gap is quite far compared to this Bestari group. You see the the distribution is actually shorter, right? The spread of the marks, the spread of the data. So the marks of this Arif group is actually we can say that is more dispersed compared to the test marks of Bestari group. Okay, more dispersed, or the dispersion is more compared. We need to do comparison between the two group for the dispersion of the test mark, right? So that is how you do. You just use your highlighter or maybe your pen, try to work out the distribution of the data. Okay, draw the line. If the line is longer, that means it is more dispersed. All right, so dispersion means how the data spread. It spread from lower to higher with a certain range, which is quite long, so we say it's more dispersed. All right, okay, so I have teach you how to do the comparison between the two set of data to observe which one is having bigger dispersion. Alright, I also teach you how to describe the dispersion. Is it almost uniform? The shape, alright, the shape is almost uniform and maybe bell shape. Now, which group, okay, shows better results? And then you have to justify your answer. You have to give the reason, right? So which group perform better? Of course, because this is the marks. Let's say it's the mark. Okay, you have two class. So obviously you can see best study group majority of the students are score 50.5 above. We consider pass. Many of them pass, isn't it? You see the number of the student. We have 4, 8, and then we have 7, we have 4. So if we add up, is the quantity of the student who score above 50.5 is more, right? So it shows that best study group is actually shows better performance. All right, you have to study the frequency and the marks. All right, and then the reason is we can say number of students who score higher marks are more, or we can say the quantity or frequency of the students is more, who score higher marks is more compared to the Arif group, right? For question number 2, let's see question number 2. The diagram below shows the survey results of traffic flow into town. Each location records the speeds of 50 car speeds. So you can see the location A is in pink color and the location B is in blue color. Then the number of cars and the speed, it seems like the pink color, the number of cars having the speed which is lower compared to the blue one, which is location B. The speed of the car is higher, and the number of car who having the higher speed is actually quite high, even though it's less than the 22. It seems like it's having 18, but the speed is higher, you see. So we can see that location B, if you compare to location A, if a place whereby the speed of the car, number of the speed of the car is higher, that means that place will be very busy, right? So it should be a town area compared to location A, whereby people drive slowly and we have less car, right? So for the pink graph, we say it is actually right skew. When it is right skew, means that it will decrease to the right, isn't it? So, and then for the location B, it looks like it's a bell shape. It's quite symmetrical, right? I mean, those speed lower and the higher they are less, and majority of the car are having mean speed, at the middle. You can see there is a bell shape. So we can identify the shape. For the location A is actually right skew. For the blue one is called as bell shape. So we need to know how to differentiate the shape of the graph. Now I want you to observe the dispersion of the pink graph and the blue graph, meaning that location A and location B, which one is more dispersed if we want to do comparison between them. So we will draw the line like this. You see, for the pink color one, frequency polygon for the pink color one, I am using the blue pen to show the dispersion. Okay, so for the location B, I'm using the green horizontal line to show the dispersion. As you can see, the green line is wider than the blue line. So our justification is the car speed in location A is less dispersed compared to the car speed in location B, right? So this is so-called general statement that you can make based on the width of the blue line and the green line, which shows the dispersion of the two graphs. So hence we can conclude that the car speed in location A is less dispersed compared to the car speed in location B. So you must do the comparison by using the terms the car speed in location A. Location A is less dispersed compare, there's a word compare, to the car speed in location B. See or not? The terms is very important. So make sure you write precisely. Car speed in location A is less dispersed compared to the car speed in location B. Right, we have complete the comparison between the car speed. Then finally, we want to write a statement to support our answer. Okay, the general statement. Now let's see how to write the justification for these two graphs. Alright, so the justification is based on the dispersion of the location A and location B, and also based on the shape right skew and the bell shape, we can conclude that the location A is actually a highway and location A is a housing area, right? Highway, isn't it? The car speed is higher compared to the housing area. So the speeds of the car are higher in the highway compared to the housing area. So that is how you write your answer. Location B is a highway and location A is a housing area. Okay, and then you write the speed of the cars are higher in highway. Alright, that's all my explanation on this topic. Till then, bye bye and have a nice day.